Next speaker is Aruna from Uppsala University, Sweden. Nanowired delivery of cerebrolysin together with monoclonal antibodies to amyloid, peptide, phosphorylated tau and tumor necrosis factor, alpha induces superior neuroprotection in Alzheimer disease, brain pathology exacerbated by sleep deprivation.
Very good.
As I told you to present this paper, can be I told you to present the paper, the same joke, so I'm doing that. Disappear. She works on sleep deprivation. And sleep deprivation is one of the major causes of brain pathology, including Alzheimer disease. And you know that.
Because
Yes. Does it cover the screen?
No.
Okay. Sleep deprivation is also a major problem in our military population. They have sometimes less than 4 hours sleep, and that can produce various brain pathologies. So I will present the work that way. Yes, these are my collaborators, I told you. And we must tell that we have no special disclosure. Whatever we are telling, it is our own personal views, not of any government organization or the universities we are working with that. As I told you that it is blood-brain barrier that is the major gateway to various neurological diseases, whether it be sleep deprivation, traumatic brain injury, even 1 night of sleep deprivation increases pathology of amyloid beta peptide in the brain. This is well known. And here you can see that sleep deprivation, accumulated amyloid beta peptide, phosphorylated tau, mitochondrial dysfunction and oxidative stress, senile plaques, neurofibrillary triangle, and apoptotic necrosis, leading to brain pathology. And that's the connection between sleep disorder and Alzheimer's disease. This is showing the brain, and this part is shrunken, development of various pathological changes, including amyloid plaques, neurofibrillary triangles, and neurons are altered.
Sorry, sir. Can you just come forward?
Okay.
The voice. Yeah. Yeah.
We don't have a microphone.
Okay.
So here we can see that Alzheimer's disease pathology improve position of neurons and interaction with glial cells and even myelin, and that is very similar also to sleep deprivation. So there is overlap of amyloid beta peptide, tau protein, alpha-synuclein, and also Parkinson's disease. So there is combination of Alzheimer's disease and Parkinson's disease caused by amyloid beta peptide, and all can happen with sleep deprivation. This is one example showing sleep deprivation can produce many changes in the brain, including increases symptoms of depression, risk of breast cancer, risk for heart disease, weight gain, increased risk for diabetes, stroke, higher levels of anxiety, and impaired cognition. We have shown in experimental model that sleep deprivation induces blood-brain barrier breakdown. And this can be produced in rat models using inverted flower pot method. It is well known. And I told you sleep deprivation in military is very common. Combat stress field manual says sleep deprivation, cumulative effect of insufficient sleep, and total sleep deprivation is very important, and we have to look for the symptoms and also the treatments. I show you one example that sleep deprivation here is compared with alcohol impairment, and you can see that both are very similar. This is sleep deprivation up to 26 hours here, and also the alcohol impairment, blood alcohol concentration increases according to the same thing. So you can see the same situation with sleep deprivation and alcohol-induced impairment of the brain. This is the example how our military personnel are spending their night or whatever the time they have to sleep and rest, and that is very difficult. This was done in 2007. So we studied sleep deprivation in animal model and measured the amyloid beta peptide as I showed you earlier. Tau is also increased, and this is the example. The amyloid deposition in the blood vessels. This is amyloid beta peptide infusion, Nanowired cerebrolysin and cerebrolysin alone, and this is leakage of albumin affected. The same thing that also the astrocytes are influenced in the same way as well as neuron. The treatment is much better here. And at electron microscopy, you can see the myelin vesiculation, and this is treated, and this is the better condition. Here you can also see the albumin, GFAP, and neural distribution. Here is pathology, and they are here much better. This is an example showing that cerebrolysin reduced the leakage of iodine and also regional blood-brain barrier changes, and also when we labeled with PLGA induced cerebrolysin. These are the data showing the CSF level, and it is significantly increased after LAP infusion, and that is decreased by regular treatments. P-tau levels were also decreased by regular treatment, as you can see here, CSF, cerebral cortex, hippocampus, and cerebellum. Amyloid beta peptide plus tau antibodies, you can see that they are significantly improved. The same thing is here, you can see that nanowired cerebrolysin and nanowired cerebrolysin plus antibodies to tau and amyloid beta peptide, the effects are better. These are the innovation awarded to my wife at that time. Co-administration of nanowired alpha-melanocyte stimulating hormone and cerebrolysin enhances neuroprotection in concussive head injury following sleep deprivation. This table shows you that amyloid beta peptide increased after sleep deprivation 48 hours, and that is decreased and further enhanced by sleep deprivation with AVP infusion, and they are reduced by sleep deprivation by nanowired cerebrolysin and nanowired cerebrolysin with amyloid and tau antibodies. Also happened with p-tau. They are increased by sleep deprivation and also sleep deprivation in combination with Alzheimer disease, and they are reduced by nanowired cerebrolysin and the combination of cerebrolysin and amyloid beta peptide and tau antibodies. We also measure 5-HT. They are also increased after sleep deprivation, further enhanced by sleep deprivation and amyloid beta peptide infusion, and they are also reduced. Likewise, blood-brain barrier and blood CSF barrier levels. This is an example of pathology: sleep deprivation with amyloid beta peptide infusion untreated and after treatment with these drugs. This is the example of vacuum microscopy. Untreated picture is here, so much destruction of myelin, and this is much better preservation, not completely protected. This is the pathological treatment of neurons, and they were significantly reduced by the drug treatment. This is sleep deprivation 48 hours. This is untreated, and this is after treatment was significantly reduced. Amyloid beta peptide, very much expressed here, that was also reduced by the drug treatments. Microglia, as I told earlier in another example, CD86, significant increase here, and here is significantly reduced by the drug treatment. At electron microscopy, much more damage of the action and around this neuropil, that is much better reduced here after the drug treatment of monoclonal antibody to amyloid beta peptide, p-tau antibodies. And just to show you the same thing, that all drugs are not working just by given nanowiring. So you have to choose the specific drugs that can be good in treatment. The methodology I told you that they penetrate the endothelial cell layer to enter into the brain compartment, and they can stay there so that protection is much better and longer. So we can say that in conclusion that TiO2 nanowired cerebrolysin with antibodies to amyloid beta peptide, p-tau and serotonin has remarkably superior neuroprotective effects in Alzheimer disease pathology following sleep deprivation. We're also working with Nobel laureate Andrew Shelley. He has some small peptides that we are going to test in our model. And I told you earlier that we have published these in several books. By Los Angeles group, this is Scholar GPS. My wife is designated top scholar in cell damage here within 5 years of her work. We have lots of support from various agencies. These are our collaborators and funding agencies. And we are from Uppsala University, Sweden. Thank you very much.